Greetings, gentlemen, and welcome to the Smart Video Lab. This is Mr. Gordon here, looking at problem 6 from the midterm review. It says here some data on someone gambling. I don't recommend it. You'll lose a lot of money. It says use the linear regression function in your calculator to find a linear model for the data sets. So we need our calculators, which luckily I let you guys borrow this weekend. And we need to enter in this table of data. So pull up your calculator. Go to home screen, new document, save changes, no. We want to add list and spreadsheet, and we want to graph the data. We're looking at two variables, the first being time in hours since noon, so let's call that time, and the second is money left. So I'm going to go with just money. Okay, so time and money. So the time is going 2, 4, 5, 6, 7, 8, 10, no, not 11, Mr. Gordon, 10, 11. And the money, he starts with 975 after 2 hours since noon, 600, 800, 500, 600. I miss you guys here to call out what I'm supposed to type in. 300, 400, and 125. So we're good. Now we go to control and then doc to add a page. We want to add a data and statistics page. Click on the x-axis to add a variable. We want to know if time or money is the independent. So does the money depend on the time, or does the time depend on the money? The amount of money definitely depends on the time. So time is independent. So that goes on the x-axis. Then we click here to add variable. Money goes on that axis. So we can see it's a negative correlation. Now we can add our line of best fit. So menu, and then we want to analyze. We want to do a regression, and we want to show the linear regression. So that's y equals negative 80.82x plus 1072.95. So I'm going to round to the nearest hundredth. I don't know why I just erased it. So again, you have to go to menu, analyze, regression. I'm going to hide it and then show it again. Menu, analyze, regression, show linear. So it's y equals negative 80.82x plus 1072.95. So we go back here and we write that in. Y equals negative 80.82x. I already forgot the number. Good thing I didn't exit out of that. So we want plus 1072.95. So that's our linear model. Now it says, what is the slope? So remember, y equals mx plus b. M represents the slope. So whatever is multiplied by the x, the coefficient of x, we call it. So the slope is negative 80.82. Now remember to explain what it means in context, which is what it asks. Explain what each means in context. That is, what does it tell us about the relationship between time since noon and the money the gambler has left? We want to think about this as change in y over change in x. So we need to consider that the denominator of this is 1. Now the numerator represents change in y, so that's negative 80.82. Our y variable is money, so that's measured in dollars divided by 1. And our x variable, 1, change in x, 1 hour. So the explanation is that he loses, because it's negative 80.82, he loses $80.82 per hour. That's not very good. The y-intercept is 1072.95, because that's the constant term in our linear function rule, or the b value in y equals mx plus b. So let's explain what that means. Remember, the y-intercept is the value of y when x is 0 along the y-axis. So that means when x is 0, when the time since noon is 0 hours, when he hasn't been gambling at all, that's how much money he had. So before he started gambling, he had $1,072.95, $1,072.95, and he's blown it all gambling. Not a good idea. Now part C asks, what is the correlation coefficient for the linear regression model? Remember, the correlation coefficient tells us how good of a fit the line of best fit is, or the regression equation is. How good does it fit the data? So it's always going to be an R value that's between -1 and 1. The closer it is to 1 or -1, the better the fit is. The closer it is to 0, the worse the fit is. So we need to go back to our graph. So you can see that it doesn't really pass through any of the data points directly, but it kind of shows the general trend. So it's going to be not the best fit, but it should be a decent fit. But to find out exactly what it is, we have to press Control and left arrow to get back to page 1.1. Now we have to scroll up to the top and select Time. Menu, Statistics, Stat Calculations. This time we want two variable statistics because we're analyzing two variables, time and money. X list is A because we put our X values in column A. Our Y list is B because we put our Y values in column B. And we want our first result. We want the statistics to appear in column C so it doesn't overwrite something we already have. Press OK. And so now we're looking for the R value. And you can see right there, R is -0.9. And in class, we actually did this a different way. So we went to Menu, Actions, or Menu, Statistics, Stat Calculations. So ignore what I just said. We actually used linear regression. Same process. X list is A, Y list is B. So just to stay consistent, we'll do it this way. And first result column C. And so I've messed it all up. Nope, there it is. There we go. So either way, we get the same R value, but let's do it the second way because that's the way we did it in class. So you start at time, you go to Menu, Statistics, Stat Calculations, Linear Regression. X list is A, Y list is B, and first result column is C. Again, I'm just repeating the process because I messed up one time, so I want to make sure everyone's on the same page. Okay, okay, so we can see there's our slope, -80.82, just like we got from the graph. There's our y-intercept, 1072.95, just like we got when we looked at the graph. And our R value is -0.9. So R equals -0.9. What does that tell us about how good of a fit? That means it's a very strong negative correlation. And it's a pretty good fit. So that's because the graph models the data points pretty well. Even though it doesn't pass through any of them, it models the general trend very well. All right, guys, thanks for watching. Have a great day.